Hey guys, so we're gonna go over the homework, the page 798, numbers 1 through 19 odd. So I have it right here. Number 1 said to use the graph to determine each limit if it exists. Then identify another function that agrees with the given function at all but one point. So when they say that, that just means like what we did in the notes with Mrs. Ardito, where we're trying to find an alternate way or taking the original function and altering it just a little bit so that we can actually plug in the number that we're using as our limit so that we can get an answer that doesn't make the denominator 0. Okay, so that's what they mean by that. So basically, what is this going to simplify down to, like we did in first semester in this class? So anyways, I'm going to start with finding the limit here. Letter A, the limit of g of x as x approaches 0, but I do want to write down the function. So I'm going to write down g of x equals negative 2x squared plus x all over x. And letter A, first part is finding the limit as x approaches 0 of g of x. Okay, so let's see if we can use the graph. So I drew arrows here. We're approaching an x value of 0, and I see that bullet hole there, as Mrs. Ardito calls it. I just call it a hole. And the y value is a 1, because remember, we're looking for the y value at that x value. So that means that the limit is 1. Okay, so we found it on the graph. We hadn't need to alter the function yet. Let's take a look at b. B is the limit as x approaches negative 1 of g of x. So negative 1 is right here, and on the graph, that's about right here. I don't know exactly what that number would be, maybe a 3. I don't know, so I could guess and say 3, or I can know and plug in a 3. So let's go ahead and plug in a 3, or not a 3, a negative 1, because that's the limit. So negative 2 times negative 1 squared plus negative 1 all over negative 1. Okay, cleaning this up, negative 1 squared is positive 1. 1 times negative 2 is negative 2. This plus minus 1 turns into just a minus 1 all over negative 1. Negative 2 minus 1 is negative 3. And a negative divided by negative is positive. It does equal positive 3. Okay. All right, so I like that one. Letter C, need to find the limit as x approaches negative 2 of g of x. The limit as x approaches negative 2 of g of x. Again, we could plug it in, so because negative 2 doesn't make the denominator 0. So negative 2 times plugging in a negative 2 plus negative 2 all over negative 2. Wow, that's a lot of 2's. Okay, so following order of operations, negative 2 squared is 4. 4 times negative 2 is negative 8. That plus minus negative 2 is just minus 2 all over negative 2. Negative 8 minus 2 is negative 10. Negative divided by negative is positive. 10 divided by 2 is 5. So the limit is 5. So I was actually able to find the limits for parts A, B, and C without having to alter that equation, but part of the problem says to identify another function that agrees with the given function at all but one point. So we need to factor this. That was one of the methods that we learned. There's no radicals, so we don't need to rationalize. Okay, or what did she call it? What was her term? I wrote it down. Reverse rationalizing. We don't need to reverse rationalize because there's no radicals. But anyways, we can factor that numerator. There is an x in common, so I'm going to factor that out. And hey, I can see ahead of time these are going to cancel. Woohoo, that's what we want when we come up with another version. All right, when I divide out an x, I'm going to have negative 2x plus 1 left. Okay, these cancel. And I get negative 2x plus 1. So the other function that agrees with this one at all but one point is g of x equals negative 2x plus 1. Okay. Since this technically is slightly different than the original, you could even call this g sub 2, but whatever, we know it's a different function. I used a different color, that kind of says it. All right, so there's number 1. Next is number 3, because we're doing the odds. Okay, so number 3 is another graph. We have g of x equals x cubed minus x over x minus 1. And I'm seeing a parabolic looking graph, another bullet hole, okay, when x is 1. All right, so the first one is that. But before I start looking at the limits, I like to write down the function because I am going to have to find the alternate version. So I want to have that ready to go. Okay. And the first limit I am finding is the limit as x approaches 1 of g of x. And I just want to point out here that if I were to plug in 1 for x in the denominator, I would get 1 minus 1, which is 0, and that makes the denominator undefined. So if I were to try to do this algebraically, it would not work. But on the graph, I can see that when x approaches 1 from the left and from the right, the y value is a 2. It's where that bullet hole is. Okay, so I know that the limit is 2. Okay, so now let's go ahead and simplify this first this time. So I notice that I need to get an x minus 1. Let's do what Mrs. Ardito does. We know that an x minus 1 needs to cancel. So what would go in here? Well, to get an x cubed, that means that this would have to be an x squared. Okay. And to get a x, this would have to be a minus 1. Did I write down the wrong thing? Yeah. So x times x squared is x cubed. X times 1 is negative x. This is why guess and check doesn't work for me. I have to do it the way that I know, tried and true. I'm just going to factor it because there's a common factor of x. X squared minus 1. You know what I'm thinking. Okay, so from here, x squared minus 1, you can continue to factor down. So I got to stick with the methods that I know work for me. Because x squared minus 1 is a difference of squares. Notice I automatically put x plus 1, x minus 1. Hopefully you guys are trained that way too. I've been working really hard with you guys on that to recognize those. Okay, and now we can see that the x minus 1s cancel. Kids, I need you to be quiet, please. Okay, so all I have left is x times x plus 1. Okay, so the reason why I decided to do it this time and simplify it is because, let's go ahead and write the function, g of x equals x times x plus 1. This is the other function that agrees with the given function at all but one point. So the reason why I'm doing it now is because when I find the other two limits, I could plug it in here and it'll be a lot simpler. I won't have to do a whole lot of extra arithmetic. So trying to show you guys how to be strategic. Okay. Where was I at? So letter B, we're finding the limit as x approaches negative 1 of g of x. Okay, so let's go ahead and plug in a negative 1 into this version. So that would be negative 1 times negative 1 plus 1. Well, negative 1 plus 1 is 0. 0 times anything is 0, so the limit is 0. And if you plugged in a negative 1 into this original problem, you would get the same thing. Okay. but they wanted you to find this anyway, so might as well use the easier one, right? All right, letter C, we are finding the limit as x approaches 0 of g of x. Okay, so if I use this again, I could plug in a 0, 0 plus 1, okay. Well, 0 plus 1 is 1, 1 times 0 is again 0, okay. So, and we can also see that on the graph. So for instance, as x is approaching 0, that means we're at the origin there, so the y is 0. And as x approaches negative 1, I don't know if you guys can see that. So as x is approaching negative 1, the parabola is crossing through an x value of negative 1 there on the x-axis. So that would be also 0. So those are the zeros of the graph there. Okay. So that's why those y values are both a 0. Okay. So we could have gotten those from the graph also. But you know what? I like them both. I like to find them on the graph, but I also like to plug stuff in. It feels right when you plug stuff in and you get an answer. I don't know. I just like the algebra stuff. Oh, whoops, not 4. We're doing the odds. Number 5. Okay, so now we're away from the graphs. It does say to use some sort of utility to verify your result graphically. So you can verify your answer by basically typing y equals and then the function into Desmos and seeing what it is. I'm not going to do that here. You guys can do that. I'm just going to show you the work behind it. And I already know that they all work, so we don't need to verify them. But you can, for sure. All right, number 5, it says, find the limit if it exists. And the limit that we are trying to find is the limit as x approaches 6 of x minus 6 over x squared minus 36. Okay. All right, so for this one, number 5, I want to factor that denominator. It is a difference of 2 perfect squares. So let's switch to blue, make it blue. Okay. Can't really factor anything out of the numerator, but the denominator is a difference of squares, like I said. So this is going to factor down to 2 binomial factors, so x plus 6, x minus 6. And then we see that these cancel, and we get 1 over x plus 6. Okay, what are we trying to find the limit of? When x approaches 6. So I'm going to plug in a 6. So 1 over 6 plus 6, oh, that's easy, 1 over 12. So the limit as x approaches 6 of this function is 1/12. Okay. Number 7, we need to find the limit as x approaches negative 1 of 1 minus 2x minus 3x squared all over 1 plus x. Now, I don't know about you, but whenever I see something like that, that gives me anxiety because I'm like, oh my gosh, it is backwards. So I'm going to rewrite both the numerator and the denominator so it is in standard form from highest degree to lowest degree because that looks way, way, way better. So we have a negative 3x squared that has the highest degree, and then the negative 2x, and then the positive 1. So negative 3x squared minus 2x plus 1. And the denominator, reorder that, x plus 1. Oh, that looks so much prettier. It's so much nicer. Okay. All right. So I think I did use the guess and check method on this particular one because it was not bad too. So like Mrs. Ardito says, we know that this x plus 1 is going to create a hole in the graph. It's going to cancel out with something in the numerator. So that means that there is going to be a factor of x plus 1 in the numerator. Okay. So I like the guess and check thing when it's a quadratic because we know that it's going to be a binomial factor times a binomial factor. So, okay, x times something to equal negative 3x squared. Well, that means it has to have a negative 3. And then to get an x squared, I need to multiply by an x because x times negative 3x would be negative 3x squared. To get the positive 1, I'm going to have a plus 1 times plus 1. 1 times 1. So let's check it real quick. x times negative 3x is negative 3x squared. X times 1 is x. 1 times negative 3x is negative 3x, so 1x minus 3x is negative 2x, and then 1 times 1 is 1. So check, that worked out. All right, so now these cancel, and we get just negative 3x plus 1. That's simplified nice. Okay, what are we trying to find the limit of? As x approaches a negative 1. So now we got to plug in a negative 1. So that would be negative 3 times negative 1 plus 1. All right, negative times negative is positive. 3 plus 1 is 4. So the limit as x approaches negative 1 of that function is 4. Number 9. All right, we're trying to find the limit as t approaches 2 of t cubed minus 8 all over t minus 2. Okay. All right, so for this one, I don't know if you guys noticed my little hint when I posted the answers yesterday, but on the PDF of the answers, I put a star next to this one, and I put use difference of cubes, because t to the third is a perfect cubed, and 8 is a perfect cube because 2 to the third is 8. 2 times 2 times 2. So we learned last semester how to factor these. It's basically going to be minus plus plus. That should ring a bell. So the first one is just because I know this is t to the third power and this is 2 to the third power. So the first one would be t minus 2, so there's my minus. And then the second factor would be the t squared. It's minus plus plus, so plus. We have to multiply these two together. 2 times t is 2t plus, and then the last one is the 2 squared. 2 squared is 4. So t squared plus 2t plus 4. Now, if you forgot how to factor that and you're like, oh, I don't remember how to do that, all you have to do is literally Google difference of cubes or sum of cubes, and they both should come up. And I recommend looking at the Math is Fun one. That one is explained really well. So yeah, that's what I recommend. Okay. Hopefully you remember those though. They weren't that bad. All right, so the t minus 2's cancel. Okay. And we get left t squared plus 2t plus 4. Okay. All right, what are we trying to find the limit of? We're trying to find the limit as t approaches a 2. So I'm going to plug in a 2. So that would be 2 squared plus 2 times, 2 plus 4. Well, 2 squared is 4. 2 times 2 is 4. Plus 4, 4 plus 4 plus 4. In other words, 4 times 3 is 12. So the limit as t approaches 2 of t to the third minus 8 over t minus 2 equals 12. All right, that was number 9. I'm going to turn the page and work on the back. We'll do number 11. Okay, so number 11, we are finding the limit as x approaches 1 of x to the 4th minus 1 over x to the 4th minus 3x squared minus 4. Okay. All right, so this one's an x to the 4th, but x to the 4th minus 1 is like a difference of 2 perfect squares. So I'm going to go ahead and factor that. So, but instead of x plus 1, x minus 1, because it's x to the 4th, an x squared times an x squared is how I'm going to get x to the 4th. And since it's a difference of 2 perfect squares, it'll be plus 1 minus 1, or vice versa. Okay. And I could continue factoring that x squared minus 1 because it is also a difference of squares. So we'll see if we need to or not. We might not need to. Okay. So I'm going to keep it there for now. In the denominator, here's what I recommend on this one. I'm going to use a different color. Let's write this as if it were a quadratic. if it were a quadratic, I would write, I'm going to change the letter to a. So a squared minus 3a minus 4. Pretend it's a quadratic for right now, okay? We'll put the x to the fourth and x squared's back in a little bit. So when I factor this down, it's an easy trinomial, so I know a times a is how we get the a squared. But two numbers that multiply to negative 4 and add up to negative 3. Well, 4 times 1 is going to be what works. And to add up to a negative 3, that means that the 4 must be negative and the 1 must be positive, because negative 4 plus 1 is negative 3. Okay, so now let's put the x's back. So to get an x to the fourth, that means that a would have to be x squared, because x squared times x squared is x to the fourth. And then minus 4 plus 1.
Mommy,
I'm busy right now, honey. No, I'm busy right now. So x squared minus 4, x squared plus 1. Like he sees me talking to myself. Come on, kid. All right, so we can see that the x squared plus 1s are going to cancel. And so all I have left is x squared minus 1 over x squared minus 4. Now, these both continue to factor. X squared minus 1 is x plus 1, x minus 1. X squared minus 4 is x plus 2, x minus 2, but nothing else cancels, so I'm just going to leave it like that. So no big deal. All right, what are we trying to find? We're trying to find the limit as x approaches 1. So I'm going to plug in a 1. And I'm going to have 1 squared minus 1 over 1 squared minus 4. Well, 1 squared minus 1 is 0. And 1 squared minus 4 is negative 3. Well, 0 divided by anything is 0. Remember, it's okay to have a 0 in the numerator, just not the denominator. Okay, so yeah. I want to point out another thing on this one is that if I would have plugged in a 1 from the beginning, 1 to the fourth is 1. 1 squared is 1, so times a negative 3, that would be 1 minus 3, minus 4. 1 minus 3 is negative 2. Negative 2 minus 4 is negative 6. And then if I plugged in a 1 up here, 1 to the fourth is 1. 1 minus 1 is 0. I would have 0 over a negative 6, and it's still going to equal 0. So for this one, I could have done it without factoring, because if I plugged in a 1, it did not make the denominator 0. So try to do that first to save you guys some work, because I didn't think about that until now. Learning curve, right? Learning curve. All right. Number 13, let's find the limit as x approaches negative 1 of x to the third plus 2x squared minus x minus 2 all over x cubed plus 4x squared minus x minus 4. Okay, we have a cubic in the numerator and the denominator. And both of these cubic functions have 4 terms. So we learned a few methods last semester. The PQs, finding the possible zeros and using synthetic division to find the roots that work. Or if it works, we could factor by grouping. And to factor by grouping, you have to have 4 terms so that you could break them in half and factor each side. You guys remember that? Should sound familiar. Okay, so I want to use a different color though. Let's use red. So let's try and see if these are going to be factorable. So I'm going to break in half the numerator and factor each side. So on the left, x cubed plus 2x squared, these two terms have a x squared in common. So I'm going to divide that out. When I divide that out, I'm going to have an x plus 2 left. And then after the break is a minus sign. And x minus 2, the only number in common between these two is a 1. But because of that sign, we're dividing out a negative 1. So when I divide out a negative 1, there's going to be a sign change. It's going to be a positive x and a positive 2 because we divided out a negative 1. Okay? All right. So, Lucas, are you supposed to be eating on the sofa? And did you ask me for that? No, you did not.
What about Sissy?
You both didn't ask. Otherwise, they're going to eat us out of house and home. All right, anyways, remember when these two are the same, that means you're doing it right and it's working. Even if they weren't the same, that doesn't mean you're doing it wrong. It just means it's probably not factorable that way. All right, so x plus 2 is one of the factors. The other factor, you guys remember the leftovers, is x squared minus 1, which we could continue factoring, but I'm going to leave it like that for now to see what the denominator is going to look like. Okay, so the numerator is done. Let's focus on the denominator. So I'm also going to break that in half and factor it the same way since it is also 4 terms. So let's see. X cubed and 4x squared have an x squared in common. And when I divide that out, I'm going to have an x plus 4 left. Okay, there's a minus after the break. And x minus 4, the only thing in common is a 1. But because of the minus after the break, I'm dividing out a negative 1, so there will be a sign change. So x plus 4. These are both the same, so it is factorable, and we're doing it right. So one of the factors is x plus 4. The leftovers is an x squared and a minus 1, so x squared minus 1. And you know what? Because those are going to cancel, I don't need to factor that any further. They canceled. Woohoo! So all I have left is x plus 2 over x plus 4. Okay? All right, so when I plug in what am I supposed to plug in? -1, what's going to happen? So -1 plus 2 over -1 plus 4. Well, -1 plus 2 is 1. -1 plus 4 is 3. So the limit is 1/3. Okay. And just to tell you, if I plugged in a -1 in the denominator right off the bat, I would have -1 cubed plus 4 times -1 squared minus a -1 minus 4. So -1 cubed is still -1. -1 squared is +1 times 4 is 4. Negative times negative is positive. That would be a +1. So -1 plus 4 is 3. 3 plus 1 is 4. 4 minus 4 is 0. And we would have a 0 in the denominator. So we really did have to go through all the work this time on number 13. Good thing that we did. All right, 15 is finding the limit as x approaches 2 of x cubed plus 2x squared minus 5x minus 6 all over x cubed minus 7x plus 6. Okay, so let's start off by plugging in a 2 in the denominator and see if it makes it 0. Okay, so 2 to the third minus 7 times 2 plus 6. 2 to the third is 8. -7 times 2 is -14. Well, I know 8 plus 6 is 14, and then 14 minus 14 is 0. Okay, so it does make the denominator 0. So that means I am going to need to factor this to simplify it. Okay, now the problem is in the numerator, if I try to break this in half and factor each side like I did in number 13, it's not going to work because I would factor out an x squared and I would have x plus 2, but there's nothing I could factor out between a 5x and a 6, just a 1, and I'm not going to get an x plus 2. So it's not going to work that way. So what's another way I can factor this? Well, we're going to have to look at the PQs. Okay, so that's what we're going to do. So I'm going to work on the numerator for right now. Do I want to use red? Oh, I'll continue to use blue. So for the numerator, the PQs, if you guys remember those, make sure you guys can see, are the possible zeros. The numerator is the multiples of 6, or the factors of 6, and then over the factors of the leading coefficient, which is just a 1. So there's not going to be any fractions, thank goodness. So plus or minus, remember, factors of 6 are 1, 2, 3, and 6 itself. So I tried a 1, a positive 1 didn't work, so I'm just going to show you that I tried a -1. So we're going to use synthetic division to test it out. And the coefficients are all I need for synthetic division. So 1, 2, -5, and 6. 1, 2, -5, and -6. Bring down the 1. 1 times negative 1 is negative 1. 2 minus 1 is 1. Do it again. 1 times negative 1, negative 1. Negative 5 minus 1 is negative 6. Do it again. Negative 6 times negative 1 is a positive 6. Boom, shakalaka, we get a 0. So x equals negative 1 is a root, which means that x plus 1 is a factor. Okay. Now, since we divided out a factor of x, this went down a degree from an x cubed, so now these are coefficients starting with an x squared. So this is a 1x squared plus 1x minus 6. So now it's a quadratic, and that we can factor down no problem. Okay. So I'm going to have, let's see, x times x. The product is negative 6. The sum has to be a 1. So it's got to be 3 and 2, because that multiplies to 6. But one of these has to be negative so that we can get a product of negative 6. But I need it to be a positive sum, so the bigger number needs to be positive, and this one needs to be negative. Okay, so these are my 3 factors of the numerator, so I'm going to rewrite the numerator now. X plus 1, x plus 3, x minus 2. Doesn't matter the order you write them in either. X plus 3, x minus 2. Okay. Now let's focus on the denominator. Okay, this one is only 3 terms, and it's a cubic. It's not a quadratic, so I won't be able to use product sum on it. But we can try to figure out what's going to work here. Okay, so I'm going to use, well, okay. We know if we plug in a 2, that makes the denominator 0. So that means that a x value of 2 is going to be undefined in the denominator. So that means that there will be a factor of x minus 2 in there. And it's going to cancel with the x minus 2 in the numerator. So what's the other factor is what we got to find. Okay, well, let's work backwards on that then. We know the original cubic is x cubed minus 7x plus 6. Let's see what's left when we divide out an x minus 2. So do you guys know what we're going to do? Long division, my favorite. Now you can do guess and check like what Mrs. Ardito showed, but this one would be kind of harder because the other factor is not 2 terms. It's going to be 3 terms, a trinomial. So, all right. What value do we need to multiply by x to get x cubed? Oh, I'm going to need an x squared, and I don't have x squared written in there. So let's rewrite this. X minus 2, x cubed. There is no x squared, so I'm going to put 0x squared minus 7x plus 6. Because remember, if there's a missing term, we have to hold its place with a 0. All right, again, what do I need to multiply by x to get x cubed? An x squared. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. But then we are subtracting, so there's going to be a sign change. These cancel. 0x squared plus 2x squared is 2x squared. Bring down the next term and do it again. What do I need to multiply by x to get 2x squared? I need to multiply by a 2x. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Do the sign change. These cancel. Negative 7x plus 4x is a negative 3x. Bring down the plus 6. Okay, what do I need to multiply by x to get negative 3x? A negative 3. So negative 3 times x is negative 3x. Negative 3 times 2 is a positive 6. Do the sign change. They both cancel. It divided evenly. So this is the other factor. So I'm going to fill that in. X squared plus 2x minus 3. All right. So now we can see that what we needed to cancel is canceling. And I'm out of room, so I'm just going to rewrite it down here. So this equals x plus 1 times x plus 3 all over x squared plus 2x minus 3. Okay, so now I could continue to factor this and make it smaller, but now since I know that whatever I needed to cancel got canceled, I don't need to keep going. I could plug in what I need. What am I finding? I'm trying to find the limit as x approaches 2. So let's go ahead and plug in a 2. So 2 plus 1 times 2 plus 3 over 2 to the second power is 4 plus 2 times 2 is 4 minus 3. So let's see, 2 plus 1 is 3, and 2 plus 3 is 5, so 3 times 5 is 15. 4 plus 4 is 8, 8 minus 3 is 5, and 15 divided by 5 is 3, so the limit is 3. So yeah, that one took a lot of elbow grease to get that one done. And you had to recall some things, but honestly, this is good review because these types of questions are also going to be on your final. You know, finding the possible zeros and long division, like you needed practice on that anyway, so it's a good review. Okay, so if you didn't understand number 15 or if you got stuck, definitely go through these steps again on your own. It'll be an excellent review for you. I highly recommend it. Okay, so that was 15. 2 more left to do. We have 17 and 19. So 17, we're finding the limit as y approaches 0 of the square root of 5 plus y minus the square root of 5 all over y. Okay, so now we have radicals, which means this is where we do the reverse rationalizing. Okay, so to reverse rationalize, we have to multiply the numerator and the denominator by the conjugate. So the conjugate of this would be the same stuff except for a plus in the middle instead of a minus in the middle. So square root of 5 plus y plus square root of 5. But we have whatever we do, oops, I made that way too big. Whatever we do to the top, pretend that's not there, we must do to the bottom. Okay? So let's multiply this out. So square root of 5 plus y times square root of 5 plus y. Whenever you multiply radical by itself, the stuff inside gets to come out. So 5 plus y gets to come out. Square root of 5 plus y times the square root of 5 would be positive square root of, distribute the 5 because they're inside numbers. 5 times 5 is 25. 5 times y is a positive 5y. I almost forgot the 5. All right, then on the inside terms, negative square root of 5 times square root of 5 plus y. So it's going to be the same thing that we just wrote, but negative. Anytime you multiply conjugates by themselves, the middle terms will cancel. And then negative square root of 5 times positive square root of 5 is a negative square root of 5 squared. But anytime you square a radical, the number gets to come out. Okay, so this is the numerator. And I'm going to leave that alone for a little bit. Yes, there's things to cancel still. I'll come back to that. In the denominator, I'm just going to write this as y times the square root of 5 plus y plus the square root of 5. I'm not going to distribute. I'm going to keep it like that. Okay, so obviously the 5's in the numerator cancel. And these canceled, right? So all I have left is y over y times square root of 5 plus y plus square root of 5. Okay, the little hole cancels finally. So I have 1 over the square root of 5 plus y plus the square root of 5. Okay, so now we can find the limit. So we could plug in the value for y. We need to plug in a 0. So that would be 1 over the square root of 5 plus 0 plus the square root of 5. Okay, well 5 plus 0 is still just 5. So the square root of 5 plus the square root of 5, now I have 2 square roots of 5. And I'm not done yet because we can never ever ever leave a radical in the denominator. So I'm going to multiply top and bottom by radical 5. And I get the square root of 5 over 2 times, radical 5 times itself means 5 gets to come out. So this becomes radical 5 over 10, and that is the limit. Okay, so that was 17. Last but not least, oops, wrong color. Number 19, we're finding the limit as x approaches -3 of the square root of x plus 7 minus 2 all over x plus 3. Okay, so now we need to, what is it called? Reverse rationalize the numerator. So I need to multiply by the conjugate of that numerator, which would be the square root of x plus 7 plus 2. Top and bottom, because whatever we do the top, we got to do the bottom. All right. And let's go ahead and FOIL this out. And remember, the middle term is going to cancel, so we might be able to skip some steps at this point. So square root of x plus 7 times itself is just x plus 7, because it gets to come out now. Square root of x plus 7 times 2 is just a positive 2 square root of x plus 7. 2 is an outside number. X plus 7 is an inside number, so the outside number just goes attached in the front because we're multiplying. -2 times square root of x plus 7 is just minus 2 square root of x plus 7. And then -2 times 2 is -4. Okay. So again, I didn't really need to write those middle terms because I knew they were going to cancel. I said it right before I did it. But I was afraid to skip a step on you guys, so I didn't. All right, so I'm not gonna FOIL this out. I'm gonna write this as the factor x plus 3 times the factor square root of x plus 7 plus 2, okay? Because remember, the limit as x approaches -3, if I plug in a -3 plus 3 is 0. So this x plus 3 factor is what needs to cancel so that I don't get a 0 in the denominator. So that's why I didn't distribute it. I'm leaving it there. Okay, I do, however, need to fix up the numerator. I have an x, and then I have a 7 and a -4. 7 minus 4 is 3. Oh, hey, x plus 3. Love how these work out. It's satisfying. At least to me it is. All right, these cancel. So all I have left is a 1 over the square root of x plus 7 plus 2. All right, I'm finding the limit as x approaches -3. So now I could plug in a -3. So square root of -3 plus 7 plus 2. -3 plus 7 is 4. The square root of 4 is 2. 2 plus 2 is 4. So the limit is 1/4. And that's it, you guys. So sorry this video is kind of long, but I wanted to explain everything because there's a lot of algebra that we've learned just over this year that was involved, and I wanted to make sure to put in a good review sort of mini lesson in there as you're watching this. So I apologize for it being long, but I really do hope that it helped. Please let me know. Give me some validation with these videos. It helps me keep going, you know, so I need encouragement too, you guys, just like you guys need it. Anyways, have a good one, and I'll see you in my next video.